Moving on to the next question, we have convert a number to hexadecimal. So we're given an integer num and we are required to return a string representing its hexadecimal representation. So let's just talk about it and let's just see what is the question actually asking us to do. For number 26, in order for a decimal number to convert into hexadecimal number, I think the best which is possible is like you could just make it a binary representation, and then after making the binary representation you just divide each set of bits into four bits and try to analyze those situation and use that table of hexadecimal as values from 0 to 15. Like for 0 to 9 it is normal, then we have A, B, C, D, E, and F representing 10, 11, 12, and so on till 15 respectively. So what's the best way is that how will 26 be represented? So 26 will be represented as something like, so if we have 16, we have 8, we have 4, we have 2, we have 1, so 16, 1, this would be the representation, right? Of 26. This would be the representation. So what we can do is, I'm missing something? No, is it? Okay. 2 raised to the power 4 plus 8 plus this would be the binary representation. So what we try to do is that we just assume that it's a 32-bit integer, and if you have a look at the constraints, yeah, it's a 32-bit integer, it's pretty much given. Then we could just divide it into set of 4 bits. So this is one set of bit, and here it would be followed by 3 zeros, and this would be one set of bit. After that, we try to analyze the hexadecimal format. In this particular case, this is represented as 10, so this would be A and this would be 1, and hence we are able to get our complete solution. Cool. Once we are able to get that particular solution, we are able to if we are processing these first elements, then I think A will first come up. Then when we'll try to process these four elements, the next four elements, one will come up. After that, what we'll try to do, we'll just reverse this combination, just as we have done in other particular questions regarding conversion of a number to a base k or something like that, or adding of strings or adding of binary strings. We have followed this particular type of pattern that we are reversing these strings because we need to return the reverse of it, that is 1a. So yeah, that's the question. And talking about some edge cases, if we talk about n is equal to 0, so n is equal to 0, it will provide an empty string because there is no particular string which is possible and the number is 0. So for that particular case, I think we'll have to handle that particular test case. So if number equals to 0, we are returning a string that is 0. For the rest of the string, I think first of all we need to just make a vector of string, which has hex, there are multiple strings, so one, two. Let me just copy it and then paste it 5 times so that better. Okay, so 0, 1, 2, and after that we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10. We don't have 10, we have A, B, then C, then D, then E, and then of course we have F. So the decimal format. So 0 will refer to this particular string, this will refer to the F15 will represent this particular string. Right? So what can we do is while num is greater than equal to greater than 0, num is greater than 0, what can we do? What can we do is we can simply take the first 4 digits, that is how to extract the first 4 bits. Extracting the first 4 bits is quite easy. To extract one so what we try to do is to extract one last bit, we try to OR it by AND. So if there's a number, we try to OR it by AND, we get that particular first digit. Suppose we need last two digits, we AND it by 1 1. Why do we do that? Because we are able to receive that particular digit, so we are able to get the last two bits. For the last three bits, we just OR it by 1 1 1, and for last four bit, we have to OR it by AND it by four ones, and that four ones is basically 15. So we just need to AND it by 15. So this will be shifting to 15. So that if I'm extracting that particular digit, what can I do is I need let me just declare a string which will be returned string result. It's an empty string at first, and I'm returning a string, then this plus equals to x of that particular number, and that number would definitely be num and 15. After this, we just shift it. How many times? We just try to shift it by 4 times, because yeah, try to shift it by 4 times. And okay, so there might be possible condition that maybe uh, this would possibly work for all the positive values. So let me just check, and okay, I need to reverse it. Yep, reverse it. Reverse. Uh, reverse. How will I reverse it? I'll just try to try reversing it. So let's begin and this thing would work for all positive integers. This is not a fine solution. This would work for all positive integers, right? If you try to submit it, you will see that it would fail for -1. So we need to do something for -1. Like we need to do something, because here it is having this condition that num should be greater than 0. Since num is -1, it's negative. We should have something, like we should be taking care of that. So what we can think of is either the number should be positive, or the binary representation of -1 is would be like 1111. This would go on till 32 times. That would be the representation, right? Binary representation of -1 would be 1111 and then 1111, and like this thing it goes on till 32 bits are reached, right? So like 8 more of these. You have 8 more of these. So this is the binary representation. So what can we think of is that till we can have a loop, we can have a loop count, we can have a loop count, we can have a loop count as 0, and while loop count is less than equal to 8, or the value of num is greater than 0, we need to execute this particular thing. We will be incrementing our loop count as plus plus, because there are max to max 8 bits which are possible, since it is 0 based indexing. So once it gets equalized to 8, we come out of the while loop, because we assume that our resultant string has already the answer. We return it, and then it works fine, it works just fine. Okay, there's a problem with that. So the problem is for 26 it is taking 111. So okay, for that we could just simply after doing this, we simply say if num equals 0, we simply return, we simply break from this while loop, because we have already reached our answer. So if num is equal to 0, that means we need not to care about anymore. And yeah, this would work. Yeah, it's working fine. So yeah, that was the solution. This condition is because it was giving wrong test case for like 0 0, because even though if the number is 0, it's still uh, operating these further computations, so we don't require that. So we have a condition: if num equal to 0, we simply break from it. So yeah, that's just it, and we try to move on to the next question, which is the power of 2. Given an integer, return true if it is power of 2, otherwise return false. An integer in its power of 2 if there exists an integer such that n equal to 2 raised to the power 6. Well, let me just tell you that after solving all those questions, you might feel that we are getting a feeling of solving some great bit manipulation in these questions. So it won't be a problem as maths and bit manipulation are somewhat related. Somewhat at some point they have some overlapping problems. So it won't be an issue that if you try to do them now because yeah, like it won't cause a problem to us. So if you just take a case n equals to 1, so n equals to 1, so power of 2 is equal to 16 is also power of 2, and n is equal to 3 is not a power of 2. Simple. One of the solutions that we can think of is we try, it's a logarithmic solution. It's a logarithmic solution. What can we do? We start from x, while x is less than equal to n, x is equal to n, uh, x equal to 2, and once that happens, once it gets equal to 2, what we try to do is say that this should be less than n, and if value of x n, we return true, else we return false, because that's the only possible solution. For x, if we assume that 16 solution, it's multiplied, so what? 1 becomes 2, 2 becomes 4, 4 becomes 8, and then 8 becomes 16. So when 8 becomes 16, we have reached that particular point where we need to come out of the while loop and say, yeah, hey, suppose there's this value, that x is particularly equivalent to n, then we could simply say that yes, it's a solution that we have reached one solution. So okay, this particular case fails because okay, so this particular case fails because right, because of the integer overflow. So the overflow is happening over here. So we need to avoid that particular overflow. So in order to avoid that particular overflow, what we can do is simply just say that if x is less than equal to int max is greater than int max by 2, simply say that if it is greater than int max by 2, just return false, because we don't need to do that, because we have already seen that if it is greater than int max by 2, there is not a single value which could satisfy this, so we can simply return false. This would avoid the overflow thing. This would simply allow the overflow to not happen, and yeah, it's working fine. So this was the solution. Another solution that we can think of is that if we have a look over the binary representation of such integers such as 1, this would be 101, this would be 1000, and 0, 1, 2, 3, 4. This is a solution. If you talk about 8, then it is like this. If you talk about 4, then this is like this. And if you talk about 2, then this is like this. So if you could have a common observation, you could see that all of these powers of 2 have one thing in common, that is they have single 1 over the entire binary in their entire binary representation. They have single 1 in their entire binary representation. For odd integers, for 8, for 4, like there can be multiple ones as well. Like you could just see about if we talk about 5. Okay, so this was 1 1. This wasn't 3. 1 1 is 3 basically. If we talk about 5, this is 1 0 1. Then I would say if we talk about 7, sorry, if we talk about 7, then 1 1 1 will have 3 ones, it will have 2 ones. 4, the value of 4 has 1 1, so we're not taking that. Try to get an even power. Let's just take an example. 32. 32 is also an even power. Let's just talk about 12, right? We talk about 12, so we can easily, or simple, we can just talk about 6. 6 is not a power of 2. It has binary representation of 110. It has two ones. So, and this is necessary. So, like, why is this condition coming for that? I should have only have 1 1, because if you remember about the binary representation, then the binary representation is like, there are four digits, like here, and so this refers to 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. If any one of them is 1, if any one of them is 1, we can clearly say that's a power of 2, right? But if there are multiple ones, like for example in this case, then it would be a sum of these two values, like 2 raised to power 3 plus 2 raised to power 2. And that clearly would signify that it won't be a value. It won't be a power of 2. That particular value won't be a power of 2. There should be only single one in the binary representation. So what can we simply do is that, since it's a 32-bit integer, I know this is also taking O of log of base of 2, and since n is a 32-bit integer, we can clearly say that it is referring to O of 32. I know this is also a very fast solution, but we could just use there's a built-in particular that what do we call it? It's a built-in method which is used to calculate the number of set bits in the bit manipulation when we are handling bits. So that would be useful to us. I could just give a small introduction to that, but when we'll try to solve questions related to bit manipulation, I would definitely bring up that there as well. So let me just talk about that particular function. Okay, so what we can do is simply there's a particular method which is by the name of built in built-in pop count built-in pop count. I'm not sure if it's correct or not. I think this is right. Built-in pop count n, and if we try to return this, let's just see what happens. Try to return it first. I'm just running it and I'm just seeing what is basically returning. So this is returning 1, right? This is built-in pop count. So what it does, it basically returns the number of set bits which are present. So if it is returning the number of set bits, then we could just clearly say that, hey, the number of set bits would be equal to 1. Then we could simply say that is equal to 1. We could simply say that, hey, this is a power of 2, else it is not a power of 2. So let's just try to submit it and see if it works or not. So it doesn't work for this particular function. It is basically returning. Okay, for negative integers, and so we can have another condition. We can have another condition, right? We can have another condition, and n should be positive, of course. N should be positive. So earlier, what we were doing, we were simply direct, we were taking x to be 1 and we were multiplying it with always 1. So it was always positive. So yeah, this is also working fine. Here it is runtime is 4 milliseconds. Basically, I have asked you not to have a look at because it's very laggy. I'll just try to submit it once and you'll see the what the problem is occurring. So yeah, you can see the runtime is again changed. So try to not rely on this particular thing. Try to analyze these problems asymptotically and using order of and theta if you need that. So that should be fine. Okay, now let's just move on to the next question, which is add to the array form of integer. Right. So we have completed this particular question, power of 2. Uh, we need to also solve the questions as well. So yeah, we'll be doing that. Okay, so this is a question. Array form of integer is given. Like instead of num, we are given the number of digits 1321. Give the number of array form of integer and integer, return the array form of the integer plus k. Okay, fine. So it's not a problem because what we can do is simply, if integers are given like this, the major thing is that we try to do addition from this side, right? If there's a 46 number which is present, we try to add these digits first, like 6 more, and then we apply carry, and then we go on further. Same thing would be doing it here as well. The only thing that should be a part of it is that first we'll try to reverse that particular not vector for our computation purposes. And so that try to reverse it again. Once we are done with computing everything, we'll try to return the same num which is present because we are allowed to do modifications to that. So for int I is equal to 0, I less than num dot size I, or what can we do is that we could have a while loop, right? We could have a while loop while I less than num dot size, or the value of carry, or the value of carry, int carry should be there, or carry. Okay, the carry thing would be handled specifically later on. That carry will be after some time, right? But yeah, should be and carry. Carry becomes 0, then we can simply say that yeah, we are done with uh, done all the additions and fine, we can just move further. But if carry is greater than 0 and the number I less than num dot size is okay, let's not try to make it more complicated. We can have something as like that. So what are we looking for? Right. So first number is given like 34. 34 is given, right? 34 is given and 181 is given. So if 34 is given, so try to add it. We try to first add it, right? Try to first add it. Try to first add it like either like if you try to first add it, we get a 0, we'll get a 5 over here, right? As carry. So what is actually happening is we are actually plus carry plus num of that I, right? Then we are adding plus equal to k, right? After that, after we have added the k, there should be some kind of value that it would be carried forward, and there will be some kind of value that uh, it should be, it should be just uh, done later on. So what the value is, num I would get changed to the value of the whole value of carry modulo that particular digit, so that would be 10, and num and the value of carry, the value of carry would be just uh, instead of modifying this function, I think we could just simply do it like num I plus equal to k, right? Num I plus equal to k. Num I is equal to uh, yeah, num I is equal to k carry carry. Once this happens, uh, we'll try to have a value as try to add it, right? Once you have tried to add those integers, what we can do is we can simply say that you know we can just simply okay. So what we can do is we can just once this happens, our function of k is over, right? Our function of k is over, literally over. So We don't need to do that. We have already added it to our that particular variable. We can just move further and compute those other additions that we can achieve. So now my plus equals to k is done. Now my we are done with adding this. Now my plus equals to carry. Now my plus equals to carry. So we're doing now my plus carry. That means we're declaring integer carry as 0. After that, now my when we are doing that, we are assuming that carry would have some value. We'll try to keep it equal to 0. Try to avoid that thing. Try to avoid that thing. Now my plus equals to carry. Once now my has all the value. So what we try to do is we'll yeah. So just now my is equal to now my okay. So value of carry. First we need to carry the value. So carry value will be num dash 10. After that, the value of num I would be num I, and this would be my yeah. This is fine to me. After that, we'll again go to the next particular I, and we'll have the value of carry as something. We'll have the value of num. The same procedure will take place, and if the value of carry is greater than 0, the value is greater than 0, we have some number, we have some numbers left, then we could have a while loop after this. While carry is greater than 0, what we'll do, we'll push back those values. Push back carry modulo 10 and carry modulo 10 carry 10. That's it. I think this would work. So yeah, the only part was okay, it should be now. The only part, the trickiest part was like uh once the value of k we have used, once the value of k has been used, we are not using it any further. So yeah, it's working fine, and yeah, it's a good solution. It's order of n, and we're trying to do it in place. You're not declaring any extra array for that. So yeah, that was the question that we were thinking of. Next up, we move on to the next question, that is arranging coins and rectangular overlap. So let's just try to move on to the question. Um, let's just try to complete all those questions which are in the tag of maths, and after that we solve around 4 to 5 questions related to bit manipulation, right? I think that will be fine.